Hey guys, so what's your first topic is on the circumcenter and the incenter. And so what these things are is you're gonna have different types of lines that are created, and it's where they intersect. Okay. And so the first one is considered a circumcenter, and your notes are filled in, but the circumcenter is created by perpendicular bisectors. So what you do is you look at every side, and what happens is you split it at a right angle, which creates the perpendicular part of it. And then the bisector part means that that point right there is going to split it in half. So to create a perpendicular bisector, you have to take the side, you have to split it in half, right in the middle, and then you have to create a 90-degree angle. And if you do this on every single side and you create that perpendicular bisector for every single side, the point where they meet is considered the circumcenter. Okay. And so when you're given that, when you have the circumcenter, you know a few things. So in number one, it says list the perpendicular bisectors. So DP is a perpendicular bisector to BA. PE is a perpendicular bisector to BC. And then PF is a perpendicular bisector to AC. The circumcenter, number two, is P. And it tells you to list all of the congruent segments. And it says the first thing is AP is congruent to BP, which is congruent to CE. So they're telling you that the segment from the vertice to the circumcenter point, all of these sides are congruent. Okay, so all of those red lines are congruent. That is really important. And then the other part down here that's listed on yours is that BD and AD are also congruent. BE and EC are congruent. AF and FC are congruent, but that's because that they are the circumcenter is created by perpendicular bisectors. Okay, so let's go ahead and start looking at some of our problems. All right, so number one, let's look at what we have. We know that Z is the circumcenter. So that means that Z was created by perpendicular bisectors. Okay, so that means the bisecting part, that means this is congruent to this side, so that means that's 19. And I haven't even looked at what we need on the problem yet. I'm just going to label all the things that I already know. Okay, that also means that this side is congruent to this side. That also means that this side is congruent to this side. Okay, so we can actually figure that out, because if we know the whole thing is 34, we can divide that in half, and 32 divided by 4. Where's my calculator so I don't accidentally get the wrong numbers? Is 17. Okay, so that means that each piece right here is 17 and 17. Okay, so then we have to add some more information. So because they are perpendicular bisectors, we know that each of these perpendicular bisectors are actually right angles, and that's going to give us a little bit more information. Okay, we also know that this length from Z or V to Z from the vertice to the circumcenter is 21. Well, in the notes, it tells us that every one of those is congruent. So that means T to the circumcenter and U to the circumcenter are also 21. So I'll list that on there. So that means that each of these are also 21. This is 21, this is 21, and then you have your other 21. Okay? So we need to figure out some of these measurements. All right, so first is TU. Let's see, have we solved for TU yet? We can solve for TU. Hold on. There we go. T to U is this side right here, sorry. T to U is this side right here, and we know it's 19 and 19, so 19 and 19 together is 38. So that was pretty easy to find, okay? And then we're gonna move on to the next one. So the next one is VY. So from V to Y. V, where's V? V to Y is here. We already found that, that's 17. All right, U to Z, I'm sorry, U to Z. U to Z is here. We know that that is 21 because we know from any vertex to the circumcenter is congruent from all three vertices. Let's see, W to V. This piece right here. Now, we do not know that measurement. We also don't know the whole measurement, so we're going to have to do a little bit extra math. So this is where the kind of the fancy part of, or the application part comes in. So if we look at that triangle, it's a right triangle. And because it's a right triangle, we have some special things. We know that the hypotenuse is 21. We know that this side is 15. And so we can solve for the third side because you guys know Pythagorean theorem. So I'm going to say my side is A, the bottom is B, my hypotenuse is C. And so then I use my Pythagorean theorem to solve for my missing pieces. So if A is 15 squared plus B squared is equal to 21 squared, then you can square those values. 15 squared is 225 plus B squared is equal to 21 squared. It's 441. Okay, to solve for B squared, I need to take away 225 on both sides. So B squared is equal to 216. And you take the square root of that, that means B is about 14.7 units. Okay, and now if this is 14.7, that means that this is also 14.7 because it's a perpendicular bisector, and bi means two, so it splits it into two congruent parts. Okay, let me get rid of all this real quick. All right, and now last but certainly not least, T to V. T to V is going to be this whole side, so 14.7 plus 14.7 is 29.4. So that is how you use all of the properties at the top to solve for your missing pieces. So let's look at this one. Let's look at number 2. Okay, so it says that H is the circumcenter. So let's first of all look at everything that we know and try to add our pieces. So we know that these are the perpendicular bisectors, which means each of those sections are congruent. So if we know CE is 7, EB is also 7. If we know the whole side of B to D is 24, that means each of these are half, so that makes those 12. We don't have enough information to apply or to know what C, D, CF, or FD are right now, so we're just going to pause on that. We do know that H is the circumcenter, and so to each vertex, B, C, and D, those measurements are all congruent. So that means that if this one is 11, that means this one is also 11, and that means this one is 11, okay? We know that all of these are right angles. Okay, so let's go ahead and see what we need and see what we already have. So G to D is 12. E to C is going to be 14. E to H We don't have that side, so we're going to have to find this side. And if you look there, you have your right triangle, you have the bottom, and you have the hypotenuse is 11. So then you're going to solve for your missing side. I'm going to label it A, and you're going to use your Pythagorean theorem. A squared plus B squared equals C squared. A squared plus 7 squared is equal to 120, or 11 squared. A squared plus 49 is equal to 121. You're going to subtract 49 on both sides. So you have A squared is equal to 72. And take the square root. And so A is about 8.5 if you round. All right. F to D, you're going to have to use the Pythagorean theorem as well. Unfortunately, the bell is about to ring, so I need to go. But you probably can do that one on your own. If you have any questions, we're going to do some more practice in a different video. And so I will link that one as well. Okay.